To summarize this collision, before we calculate momentum and kinetic energy before and after, in the original frame, we had 2 kilograms, 6 meters per second, 4 kilograms, 9 meters per second. In this direction, velocity of the center of mass was negative 4 meters per second. After the collision, the velocity of the center mass is unchanged, still negative 4 centimeters per second. The 2 kilogram object at negative 14 meters per second, 4 kilogram object at plus 1 meter per second. We got that by transforming or just changing our frame of reference. We went from the original frame to the center of mass frame. Having calculated the velocity of center of mass, we calculated the velocities of the two objects relative to that center of mass, and we got 10 meters per second and negative 5 meters per second. Again, this object overtaking this one at 5 meters per second, negative 9, negative 4, net of 5 in this direction. That's the velocity of the 4 kilogram, and the 6 meter per second approaching the negative 4 meters per second, velocity of 10 meters per second. In the center mass frame, after, we just reverse those two velocities. It's that simple. Of course, you want to understand the proof of why that works, but for right now, that's what you do, okay? So that just reverses the 10 meter per second here and the 5 meter per second here. I'll observe that that maintains kinetic energy, because your 1/2 mv squared for this object is calculated by squaring 10 meters per second. In this, before the collision, after the collision, you're squaring negative 10 meters per second. I didn't have my negative on there. Similarly, you're squaring the same number, except you're squaring a negative here and squaring a positive here. And of course, when you square, you get a positive. So that the sign doesn't make any difference. So you got this object has exactly the same kinetic energy after as it did before in the center mass frame. This object exactly the same kinetic energy after as before, again, in the center of mass frame. I'll also note that in either frame, the collision occurs at the center of mass. Wherever the center of mass happens to be at the instant of collision, that's where the collision occurs. And in this case, the velocity of the center of mass is 0, because the center of mass system is the one that stays with the center of mass. It's the system in which the center of mass is stationary. That's the basic definition of your center of mass frame. So in the center of mass frame, the momentum before equals momentum after is 0, because after collision, everything is at the center of mass. And since it's at the center of mass and stays at the center of mass, it has 0 velocity with respect to the center of mass. So the momentum before, momentum after is 0. Of course, you can plug in the numbers. 2 kilograms times 10 meters per second is 20 kilogram meters per second. Negative 5 meters per second times 4 kilograms is negative 20 kilogram meters per second. When you add those, you get 0. Same here. Okay. Now, to get the final result, though, in the original frame, we go back to the frame where the center mass is moving at 4 meters per second in the negative direction, and we transform these velocities to the velocities in this system. The negative 10 meters per second relative to the center of mass here becomes negative 14 meters per second relative to the moving center of mass here. The 5 meters per second relative to the stationary center of mass becomes plus 1 meter per second relative to center mass moving at negative 4 meters per second. And we can calculate in this system, which is our original system and where we want to get our final results, we can calculate the momentum before, 2 kilograms times 6 meters per second, negative 9 meters per second times 4 kilograms. Those add up to negative 24 kilogram meters per second. After, we got 2 kilograms at negative 14 meters per second. That's negative 28 kilogram meters per second. 4 kilograms at plus 1 meter per second is plus 4 kilogram meters per second. Negative 28 and 4 is negative 24. So this calculation here comes out the same as this one. And we can also do the same thing with kinetic energy. Okay, just doing the 1/2 mass times velocity squared, 1/2 mass times velocity squared. We get the same result here as we get here. So that kind of concludes the analysis and some important characteristics of completely elastic collision.